Greetings fellow YouTube viewers. Today in this video we will be learning how to convert a straight line into an equation and an equation into a line. So first we take an x-axis, which we can see over here in blue, and a y-axis, which we can see over here in red. So a y-axis is basically a straight line upwards, a vertical line, and an x-axis is a straight horizontal line. So now that we have an x-axis and a y-axis, which is already labeled 1, 2, 3 going up, and -1, -2, -3 going down, that's the y-axis, and same for the x-axis. And here we can see a line, a straight line drawn in black. Let's call this line L. Okay, so L. This will just help make things simpler, although you could just refer to it as the line as well. So now, how do you describe this line? Well, it's straight, it's going upwards, and it's also cutting the other two axes. Well, let's come up with an equation, okay? An equation which includes its slope, and which also includes the intersection. So here we have the slope and the intersection, okay? So we need to find an equation that relates the y, or how tall a point is, or how deep it is, to the x, how far to the right or to the left it is. So that equation is y equals, and let's use, say, green for the intersection. We call this the y-intercept. So this intersection is called the y-intercept. It's spelled with a P. So y-intercept. So at the y-intercept, we have the point, which is shown in green, where the y has a certain value, and where the x has a value of 0. So where does the line cut the y-axis? Where does it intersect the y-axis? That's the y-intercept. We also talked about the slope. So this is the y-intercept, but what do we call a slope? Well, in mathematical language, a slope is called a gradient. So gradient. And we can use the letter M and the color orange to represent that. So slope is gradient, right? So if you have a greater slope, it means you're going further up for every distance you travel to the right or so that is called the gradient, and it's represented by a capital M. So just remember that y is equal to m something c. But remember, we've only mentioned the y value. What about, so the y value in red, we've only mentioned the y value. What about how is it related to the x value? Well, y is equal to m times x, so mx you can write, or m times x if you want to write it long, and then add c. So y equals mx plus c, and this is the equation we will be working with, and this will be very important in the times to come. So let's try and describe the line L. So we have a line L that's been drawn on a plane, a number plane. This is called a number plane, with an x value and a y value, where every point has an x value or y value, and there's the x-axis and the y-axis. This is called a number plane. So we want to calculate the y-intercept and the gradient in order to describe it. Well, we can already see the y-intercept, right? So we can see where it's marked in green. We can just look at it and say, well, the y-intercept is 2. But what about the gradient? How would you describe the slope of a line? What if we drew another line like this? Would that be steeper? Yeah, of course it would. Because if you were going up a mountain, and you went up this line, it would be much harder for you to go a single meter further than it would be if you were going on this mountain. Or it would even be even easier. It would be even easier if you were going on a mountain that was more flat. What about skiing? A lot of us go on ski Fridays. What happens in skiing? Well, in skiing, we have a negative gradient. So you're going downwards for every time you travel forward. And so this is a negative gradient, and slowly it gets steeper and steeper. This means its gradient's absolute value increases. So the gradient is getting steeper. But because it's in the negative direction, it's actually getting less. But in the positive direction, the gradient is getting more. So you have a pretty good idea of gradients as slope. But let's think about that again. So a slope, what did we say for that? We said how much distance forward, so forward, and we also said it's important to say how much distance it goes forward and how much distance it goes up or down. So up/down. So up or down matters, and how much it goes forward or backward matters. Well, if you notice, forward is the same as the x value. So forward can be represented by x. And up and down, so we'll just say up for our purposes. Up can be represented by the y value. So we find that we can use just the x value and the y value of a line in order to calculate the gradient. Now let's think about it. What's the easiest way of making a line? What's the easiest way, single easiest way? You take 2 points. So you take point 1, you take point 1 and point 2, and you just join them by a line. That's it. And that's how many points we need to calculate a gradient. Just 2 points. So if you have 2 points, you can figure out the gradient of a line. So let's try and figure out the gradient. So we know the y value and the x value of 2 points. Let's take 2 points and we'll mark them in pink. So let's take this point, which is, what are the coordinates for the pink point? Well, let's look at the x value, right? What is the x value? The x value, as we can see over here, is -1. So -1, comma. What's the y value of this point? What is the y value? The y value is 0. So it's 1, 0. So we can describe this point as 1, 0. And now let's take another point on the line. Let's just use the green point, okay? So for the green point, what's the x value? The x value for the green point is, let's look, it's 0. The x value is 0. But what is the y value? So it's 0, comma. What's the y value? The y value is 2. So now we can use these 2 points, point pink and point green, in order to calculate the gradient of a line. And the formula for this is equal to m is equal to rise over run. So rise, which we can substitute as delta or the change in. Let's just write change in because it's simpler terminology. So the rise is change in y. We can also say delta y over the change in run. So run can be said as delta x. So the gradient is delta y over delta x. What does this mean? It means basically delta y means y1 minus y2 minus y1, and delta x means x2 minus x1. So using this formula, we can find out whatever gradient for the gradient for any line. So let's try and calculate it for this line. So we already know the x values and the y values. So let's call the pink point 1, and let's call the green point 2, because 1 is to the left and then 2 is more to the right. You can use either. So what is the y value of 2? The y value of 2 we can write as y2. What is y2 equal to? Y2 is equal to 0. So we can use pink for this, since both of them are y values. This will make it a bit clearer. So 0 minus y1. What is y1? Forgive me, it's actually 2. So what is the y value of 0.1? Of 0.2? The y value of 0.2 is equal to 2. What's the y value of 0.1? That's y1. So what is y1? Let's look. y1 is equal to 0. So we'll mark that in green. So 2 minus 0, and then all divided by, what's x2 equal to? Well, x2 is the x value of 0.2. So that is equal to 0. And what is x1 equal to? x1 is equal to negative 1. So 0 minus 1. Or if we can write that in pink, 0 minus 1. And so here we have the equation. Now remember, when you have double minuses, it becomes add. So 0 plus 1, right? So it's 2 minus 0, which is the same as 2, divided by 0 plus 1, which is the same as 1. So is equal to 2 over 1, or m is equal to 2. And so now we know the value of m. So we can just substitute that in. Y is equal to 2x plus c. What is the value of c? Well, how tall, how high is the y-intercept, the green point? How tall is it? Let's look. It's not 1, but 2 on the y-axis. So we say c is 2, just from looking at that. And so we can substitute c in for 2. And this means we have an equation that will describe this line. If you given this line, you can use this, the gradient and the y-intercept, and substitute in the values into the formula of y is equal to mx plus c. And you can get, for this line, y is equal to 2x plus 2. Now you will be able to describe this line. So if anyone asks you to describe this line, you can say, well, it has y is equal to 2x plus 2. And that will mean that y has a gradient of 2, which means for every 1 meter it moves along, it moves 2 meters up, plus 2, which means it's 2 meters, it starts off at the second floor. It starts off 2 meters tall. So it's like if you imagine like a plane, then you can see this example as a plane that starts off 2 meters above the ground and then keeps on going even taller, gains 2 meters upwards for every 1 meter it goes. So this is how you can completely describe that. Now you might be wondering, well, how is this useful? How will this help me? Well, here is how it will help you. Say you have a point on the line, right? You take this point, and let's mark this again in pink. So you have this point in line, you have this point on the line, right? And you want to see what its y values are given x, or its x values are given y. So say you know, which we know already from this, that the y value is 3. So y equals 3, right? So we know that the y value of this point is 3. What is the x value? So now we substitute into this formula. So y equals to 3. Therefore, 3 equals to 2x plus 2. 3 is equal to 2x plus 2. So we can subtract 2 from this to find that 1 is equal to 2x. So we find that x is equal to 1 over 2, or x is 0.5, or a half. Now we use this equation to find out that actually, even though it looks that way, even though it looks like the x value is 1, it's actually 0.5. And this is why this is such a useful tool, because you can use this to precisely determine fractions. You don't have to say, oh, it's somewhere around 1, oh, it's somewhere around 0.5, oh, it's somewhere around 0.75. You can say exactly it is 0.5. Another useful tactic that you can use after knowing the description of the line through the equation y is equal to mx plus c. What you can do now is that you can realize what will happen on this line if x is equal to 1000, right? So x is equal to 1000. You don't have to sketch the graph and make it big enough so that you have 1000 on x and 1000 on y. No, you can simply use the equation without even having to do anything else, without having to physically sketch it to 1000, which in some cases would not even be possible. You are still able to find the y value. So y is equal to 2 times 1000, or 2000, plus 2. Y is equal to 2002. There, in 2 steps, you have done what would take you a very long time if you tried to sketch it out. But you've just done it in 2 steps with the help of an equation. Now next week, we will show you how to create a line, draw a line, when you're given an equation. So the exact opposite of this. So in here, you were given a line, and we drew an equation. From that, we made an equation. Next time, we'll be given an equation, and we will learn how to draw lines from equations. Thank you for viewing. If you like this video, don't forget to like, subscribe, and comment. This is Aaditya Rawat for Compendium.